Alright, in this section we're just going to do a quick review of some of the newer Gen 2 adapters that are now available with UCS. We'll discuss the differences briefly. So here we have the CNAs from Emulex and QLogic, and these are the Gen 2 versions of the CNAs. Now in Gen 1, the main difference was that there were several different chips on the adapter. You had a traditional fiber channel ASIC, you had a traditional Ethernet ASIC, and then you had another ASIC provided by Cisco called Menlo that really act as the muxing bridge to bring both fiber channel and Ethernet together into a data center Ethernet uplink. But with the Gen 2 versions with Emulex and QLogic, what each company has done is to provide all of that functionality into their own single chip. So what that's allowed them to do is to provide a lower power footprint and really more of an optimized form factor with less heating and power. So it's a single ASIC design in both cases with both Emulex and QLogic, and compared to Gen 1, the traditional fiber channel chip that was on the Gen 1 adapters is capable of 4 gigabits of fiber channel. The newer Gen 2 adapters in both cases are capable of 8 gigabits of fiber channel. Now of course that 8 gigabits of fiber channel is encoded or wrapped or encapsulated into Ethernet for FCOE, egressing the adapter. And all of that FCOE encapsulation is also provided by the same ASIC. Now from Gen 2, remember I said that, well, in Gen 1, Cisco provided the ASIC called Menlo to provide that data center Ethernet conduit. Well, now that both Emulex and QLogic have done that in their own ASICs, one of the things that was left behind was fabric failover. So the Menlo adapters in Gen 1 of Emulex and QLogic were able to provide fabric failover. But now that the Menlo ASIC is no longer there, fabric failover did not make it into either the Emulex or QLogic Gen 2 adapters. Now that doesn't mean that you won't have high availability with these adapters. Of course you can, because you can use typical NIC bonding, NIC teaming configurations just like you've always done. So just something to keep in mind if you're planning on using fabric failover in your design. That's not available in the Gen 2 adapters for Emulex and QLogic. But if you have a particular application stack that is certified and requires the Emulex or QLogic drivers, these are obviously adapters that you will need to do to maintain that support matrix for that application. Now let's take a look at another set of Gen 2 adapters, and these are Ethernet only adapters. So these are not hardware-based fiber channel over Ethernet CNAs. These are just strictly IP only Ethernet adapters for basic 10 gig Ethernet connectivity with IP connectivity to the server. So this would be put in a server where you really don't have any requirements for high performance fiber channel over Ethernet. So one of the adapters is from Broadcom, and there's another adapter from Intel. The Broadcom adapter is interesting in the sense that it provides iSCSI acceleration and iSCSI offload in terms of a hardware iSCSI HBA. And potentially we can leverage that in the future, in the very near future, with UCS to do iSCSI booting of servers. So that's interesting. And same here with the Intel adapter. What's interesting about the Intel adapter is FCOE capabilities in software. So this adapter basically offloads FCOE to the server CPU, and that might present some interesting use cases for fiber channel over Ethernet moving forward in the future. In both of these adapters, because they're Ethernet only, come at a lower cost point than the other CNA adapters. And again, like we saw with the Gen 2 Emulex and QLogic adapters, there is no fabric failover capabilities with these Ethernet only adapters. So you will not be able to leverage fabric failover, but as you would with any other installation, you can leverage the typical NIC bonding and NIC teaming configuration to provide high availability to the OS or hypervisor that is leveraging these adapters. Then of course we have the Cisco Virtual Interface Card, VIC, or otherwise known as PALO. Now this is really still technically a Gen 1 adapter because it's still, the shipping version we have now is still the first version of this adapter, but it provides a lot of high capabilities in terms of virtualization and performance, and is really the most popular adapter used with Cisco UCS. It has about an 80% attach rate. It is a converged network adapter. It supports fiber channel over Ethernet in hardware. It can be defined to present itself as many as 58 different virtual adapters to the server that's utilizing it. So any combination of Ethernet or fiber channel, each one of these virtual adapters presents itself on the PCI bus as a unique physical adapter. And each one of these virtual adapters has its own virtual cable that runs all the way up to the fabric interconnect to its own virtual Ethernet port. And all of that is dynamically provisioned when you define this in the service profile. It also has the capability to integrate with VMware in a technology that has been called VNLink in hardware, and we're now calling it VMFEX. And that's basically where the fabric interconnect is acting like a hardware version of a distributed virtual switch. And these virtual adapters on the Palo are really hardware implementations of the ports of that distributed virtual switch. We'll talk about that in a moment. There's also rich QoS capabilities with the Palo adapter. You can provide minimum amount of guaranteed bandwidth to each one of these virtual adapters that you define with no maximums. So each virtual adapter can use the full 10 gig of bandwidth if it's available, but if there is congestion on the adapter, you can at least provide some minimum guaranteed bandwidths to those adapters that you choose. So with the Cisco VIC installed into an ESX host in a VMware implementation, you have the option of using a technology called VMFEX. This was previously named Hardware VNLink. The name was recently changed to VMFEX. And basically what you're doing is the Cisco VIC is really at this point a second tier fabric extender and is giving each virtual machine a virtual cable that runs all the way up to its own virtual Ethernet port on the fabric interconnect. So on the CSX host, there really is no Nexus 1000V or VMware vSwitch. The fabric interconnect is now a hardware implementation of a vSwitch or a distributed virtual switch. And the virtual machines themselves, although I'm not showing them here, they still maintain their same software, VMX Net 3 driver, all of that stays the same. There's no changes required there. And you're basically passing through the hypervisor. vMotion still works. All of that functionality is still there. So you have virtual machines logically connected with their own cables to their own ports on the Fabric Interconnect, just like all of the other physical servers are. So you're really managing all of the VMs and all of the physical servers in a very similar way in terms of policies, in terms of settings and profiles and visibility. And there's an API integration from the Fabric Interconnect directly to VMware vCenter. So from the perspective of VMware vCenter, it sees the Fabric Interconnect here as a distributed virtual switch, and these are the VMs that are attached to it.